Hey everyone, good morning, and this is Yarin sir for your physics class. So, எல்லாருமே present அப்படின்னா ஒரு வாட்டி உங்க attendance போட்டுருங்க சரியா? Make sure you just put up your attendance. Okay, let's start our session. So, who are all here? Okay, first thing, everyone can hear me. Am I audible to everyone? Yes. So I can see the emojis starting to flow, right? So now you don't need to raise your hand. Actually, you do have the emojis, so you could use that also. Okay, so that's a good way to express. Do you understand the class? Do you have any trouble also? So make sure you use that throughout the class. Okay. And so I think we are all pumped up, charged up. Yesterday, you all did exceptionally well. Okay. I think we started slowly, but when we started to solve the problems, many of you started answering very fast, which was very, very happy for me. Okay. So from yesterday, today we are going to increase the pace a little bit more. Like I said, okay, each and every day what we are going to do is we are going to increase the pace of our classes more and more and more, so we will be a little fast than yesterday. Okay, and today what are we going to learn? Now that's an interesting question. We are going to learn two chapters. One is laws of motion, the other is work, energy and power. And yes, I do know in 12th standard it's a very, very, very vast big topic. I mean, not in 12th, in 11th, right? When you were studying 11th, these were very, very vast and large topics. It had lots and lots and lots of formulas. But when it comes to entrance examinations, and that too, Viteee or Srmjee or Aeee, they ask questions only from certain specific topics first. Okay, most of the questions, like literally 99.9% of the questions, they come from certain topics only. Okay, and I did discuss these topics yesterday itself, right? I said to you that 30% of the questions come from 11th, whereas 12% of questions come from our 12th standard, right? And what are these 30% of chapters that are from 11th? One is kinematics, which we have completed yesterday, right? The other is laws of motion and work, energy and power, which we are going to complete today. Now, okay, next 2 hours, we are going to complete these chapters, the problems from these chapters. And the remaining is gravitation and properties of matter and thermodynamics or thermal properties of matter. So these chapters we will discuss in the upcoming classes, right? So now let's start with laws of motion and work, energy and power. Okay, so we'll start the class, but before that I want you to know two very basic formulas in this chapters. Okay, before we go into problems, before we dive into deeper concepts, I want you to know very simple basic two formulas. One is the formula for force. You can write force as mass into acceleration, and I think everyone knows this, right? The other is a formula for momentum. See, the formula for momentum is mass into velocity. So one formula is force, the other is momentum. I want you to remember these two formulas. If you remember these formulas, no matter how hard the question is, you can find a way to solve them. Okay, you will always find a way to solve them. And how this works, that I will explain it to you, right? So everyone is ready. Okay, can we start the session? Can we go and dive into the concepts? Yes, because I'm looking at your comments, at your reactions, emojis, whatever it is. I want you to keep on expressing throughout the class. Okay, so yeah, so lots of thumbs up is flowing. And just a second, let me just see that the comments is also working. Yes, so Shivaranjani has said good morning, sir. Good morning, Shivaranjani, and good morning, actually, everyone. Yeah, okay. Verithanama start pannalam, Harshil. Okay, Harshil, sure. So let me just switch to the other tab. The other tab where I can see your this tab is better. Here I can see the doubts. So yes, we are going to start very thanamly, right? So first, okay, we are going to see about conservation of momentum. The first topic you're going to learn today is what? Conservation of momentum. So what is conservation of momentum? Okay, that is what first we are going to understand. And for that, we are going to consider two particles, particle 1 and particle 2, and they are colliding with each other. Okay, they are colliding with each other with two forces. One of the forces F1 vector, the other force is F2 vector. They're colliding. Okay, so what they are saying here is the forces that is acting here, no, F1 vector and F2 vector, we are going to represent them in terms of force. Okay, we are going to represent the momentum in terms of force. So in terms of momentum of particles, the force on each particle can be written as, okay, F1 vector. Okay, the force can be written as what? F1 vector equal to differentiation in P1 vector, that is the difference in momentum on the first particle divided by change in time dt. And for the second particle, the force acting F2 vector can be written as difference in momentum of particle 2, so P2, okay, divided by again difference in time dt. So generally we can write force in relation with momentum as differentiation in momentum dp divided by differentiation in time dt. This is a basic formula. Okay, sir. Now what is the issue? What am I going to learn here? Okay, the most important thing we are going to learn here is, see, both the particles, okay, particle 1 and particle 2, before collision they had some momentum, right? So that momentum, the total momentum, should be equal to the momentum even after collision. Okay, even after collision, the total momentum, get my words very clearly, I'm not saying, okay, the individual momentum, I'm talking about the total momentum. It should not have changed, it should have been remained conserved. So I will just break it down even more simply for you. Okay, so what they are saying is, we have calculated the two force formulas here, right? F1 and F2. Okay, so we are going to say that they are equal to each other. Okay, dp1 vector divided by dt should be equal to dp2 vector divided by dt. Sir, but wait, you have done something here, you have put a minus sign here. Why, sir? Because both these forces are in opposite direction, they are opposite to each other, so they are in opposite direction. That's why I put the minus sign. Okay, so what happens is, I'm going to add these two forces, okay, dp1 vector divided by dt and minus dp2 vector divided by dt. So I'm going to bring this to this side, so the minus becomes plus, and when I add both of them, the answer I will get is 0. Okay, the answer I get here is what? 0. And again, what I'm going to do is, I'm going to take few terms common. And what are them? D divided by dt and d divided by dt. They are common to both these sides. So d divided by dt, I take it as common. Then the remaining terms within the bracket is P1 vector plus P2 vector, which will be equal to 0. Okay, so from this equation here, what are we understanding? Okay, sir, you have taught me the derivation. From this, what am I understanding? Here, the P1 vector plus P2 vector, the term within the bracket, okay, it implies that the momentum is always a constant vector. The momentum is always what? Constant. Okay, so P1 vector plus P2 vector is the linear momentum of the two particles. Okay, so from this derivation part, what we can understand here is, okay, the total momentum before collision and the total momentum after collision, what? It remains same, it does not change. This simple concept will help you to solve lots of problems. In fact, many problems, okay, to understand many problems, you need to know this. Okay, so I will also say some examples for you. So by that way, it will be very simple for you to understand. For example, firing of a gun. Okay, see, I will take an initial scenario. In this initial scenario, there is a gun and there is a bullet. Okay, but they are all separate. Okay, I haven't fired it yet. Actually, the bullet is not fired yet. It is in rest, as well as the gun is also in rest, which means the linear moment of the system. Okay, the linear momentum of the system should be what? 0. Why should it be 0? Because both the gun and the bullet, they are in rest, they are not moving. Okay, so what I'm going to do is, in this rest position, okay, I'm going to take the momentum of the bullet as p1 vector, and the momentum of the gun before firing, okay, before firing, the momentum of the gun I'm going to consider as p2 vector. Now what I'm going to do, okay, I'm going to just add the values of p1 vector and p2 vector. Since they are at rest, definitely the momentum is going to be what? 0. p1 vector plus p2 vector will be 0, since they are already in rest. Now what I'm going to do is, I'm going to fire the bullet. Okay, I'm going to fire the bullet from the gun, which means, okay, due to Newton's third law, the gun will recoil backwards and the bullet will move forward, which means both these particles, they have some momentum here. Okay, they have gained some momentum. Initially they were 0. Okay, p1 was 0, p2 was 0, but now they have momentum. But what happens here is, okay, the recoil happens in the backward direction, whereas the bullet moves in the forward direction, which means both the momentum are in different directions. And when you add them again, they gained some new momentum, right? Which is, one is p1 dash vector. Okay, last time we just wrote it as p1 vector. Here we put up a dash. Okay, we have put up a dash here. So p1 dash vector, p2 dash vector. These are the two new momentums. So again, if you add them, okay, if you add both these momentum again, then you will get the answer again as 0 only. Again, the answer is going to be what? 0. So the basic thing here is, okay, why is it 0? Because the bullet moved forward, whereas the gun recoiled backward. So the directions for them were different, and the momentum is a vector, so it depends upon the direction. So for the forward bullet, you will take it as positive, and for the backward, you will take it as negative. Okay, so moment of the gun, when you're adding, you will take the value as negative, and when you add them, okay, the final answer will be what? 0. So you just remember this concept, okay, and I will tell you how you should apply it in a problem. When there is a question based on this concept, how should I solve it? Well, that's a separate thing. First, you have to understand that this concept. When we get to the problems, I'll make life much easier for you, which is now. So first, okay, we are going to start from level 1. Okay, so yeah, the option A. Oh, it is for the another chapter. Okay, so we are going to start from level 1, right? So here is a question. A raindrop of mass 0.1 gram is falling with uniform speed of 10 centimeter per second. What is the net weight of the drop? What are they asking? They are asking the net weight. Okay, so what is the net weight, and what have they given? They given the mass. The mass is 0.1 gram. Okay, and then they given uniform speed, which is v. So it is 10 centimeter per second. So how can we find the answer? And do you have any clue? Do you have any prediction here? What can be the answer? If you have any prediction, Abdina, please put it in the doubts or comment section so that I can see it. Okay. Just a second. I'll just see if there are any doubts also. So there are some answers now. Okay. So what are the answers? Weight na mg dana sir. Yes, the formula to find weight is mg. Okay, fine. Good. So PV is equal to, momentum is equal to mass into velocity. So momentum formula we can use. Okay, says Kamalika, I think so, right? It disappeared. And Pooja Sri says, okay, that is in different class. Okay, fine. See, the thing is, some questions might look very, very, very easily doable. They will be very, very looking easy. but there will be a small twist in those questions. Okay, it is a question like that. Here, what they are saying is a raindrop of mass 1 gram, 0.1 gram is falling with uniform speed. In fact, the most important clue here I saw is falling, the word falling. And what they are asking? Weight. So I'm going to tell a very, very, very important thing to you. Please pay attention and listen to me. It is going to help you to solve lots of problems. Okay. And what is it? Simple. When an object is falling down, when it is in free fall, its weight is zero. You don't need to calculate. You don't need any formulas. You don't need to do anything. You have to look for two words in a question. If they say an object is falling, an object is dropped, an object is falling under gravity, like these words you're looking, and they are asking you to find the weight. That means definitely the answer is what? Zero. Weight of a free falling body is zero. Okay, so but why is it zero? It is falling, okay, but why is it zero? See, when an object is falling, okay, it gets accelerated, right? What will happen? It will get accelerated. And what will be the acceleration? 9.8 meter per second square. But what are they saying here? They are saying it is falling with a uniform speed of 10 centimeter per second. It is not technically accelerating. It has a what? Uniform speed. And if it has a uniform speed, then acceleration is equal to what? Zero. If you are going to put weight, okay, which is mass into acceleration, and for acceleration you will substitute g, but here the value is what? Zero. So the weight is also zero. So the most important clue here is falling and weight. For a free falling body, the weight is what? Zero. Have you all got the point? Everyone understood this part? And if you have understood Abdina, like put up some emojis so that I can understand. Yes, super, fine. So it's a very simple question, right? But look at the twist here, right? We thought we have to solve this, okay, but turns out no, you don't need to. Okay, here is another question. A 10 Newton forces applied on a body produces an acceleration acceleration of 1 meter per second square. The mass of the body is a very, very straightforward, simple question, and this time you can solve. Okay, there is no twist in the question. It is a very direct question. You can solve and you can actually tell me the answer. Okay, here what are they asking, or what have they given? They given the force as 10 Newton and the acceleration is 1 meter per second square. Those are the values given here. Okay, what are they asking? Mass. What is mass? So I think most of you would have found out that the formula you have to use here is force is equal to mass into acceleration, right? Then if you want to find mass abdina, then you have to divide force by acceleration. And what is force? 10 divided by acceleration is 1. So of course the answer is going to be what? 10. So these are level 1 questions, but these have been, okay, these questions have been asked in entrance exams, which is very surprising, right? Pretty straightforward, pretty very easy question. But actually they have, what have they done? They have asked this in Aeee. They have asked this in Srmjee. Okay. So sir, but Viteee, okay, Viteee will be somewhat harder, right? Yes, and that's why we are going to solve questions from that exam also. Okay, we are going to solve questions from the one also. So I think now you have all got the points, right? Now we will move on to problem 3, a somewhat harder one, okay, which is from Viteee. So a particle having mass 0.5 kg is projected under gravity with a speed of 98 meter per second at an angle of 60 degree. The magnitude of change in momentum of the particle after 10 seconds is. So what are the things they have given? They given mass, which is 0.5 kg. It is projected under gravity with a speed. So they given the velocity 98 meter per second. Fine, super. They given an angle which is 60 degree. I don't know why this angle here. Okay, maybe while solving we can understand. The magnitude of change in momentum of the particle after 10 seconds is what they are asking here is they are asking us to find change in momentum. Okay, what is the value for it? And I at the start itself said the general formula for momentum to you, right? So what are the formulas that we can use here? How can we solve this? That's what we have to think first. Okay, so you know that momentum is mass into velocity. So to solve this question, you need mass. Is mass is present in the question? Yes, it is present. 0.5 kg. Okay. And you need velocity. And is velocity present in the question? Yes, there is 98 meter per second. Yes. But is it the exact velocity that we have to use in this question? Okay. That is the thing I want to ask you. Okay. Is projected under gravity with a speed of 98 meter per second at an angle of 60 degree, right? So, what will be the answer here? Okay, so they've given the velocity as well as mass. So simply you have to directly multiply and tell me the answer. Can you try it? Okay, I just want you to try it. Change in momentum is equal to 0.5 into the value for velocity here is what? 98 meter per second. So what will be the answer? I'm going to look at the chat so that I can find your answers here. 49, sir. Okay, so who has answered? Sai Geeta has answered 49. Okay, super. Very good, Sai Geeta. Others, I want you to come up with your answers. I want you to multiply 98 with 0.5. 49, sir. 49, sir. Super. Shivaranjani has also answered. Very good. Very good. See, I don't actually want you to multiply. All you can do is 98 divided by 0.5. You can write it as 1 by 2, right? So divide 98 by 2. That's it. Directly we'll get 49 meter per second. Right? It's a very simple sum. So even in Viteee2023, you can find that the questions they have asked is actually technically very, very simple only. They're not asking very complex questions which are present in, say, JEE advanced or NEET level questions. These questions are very, very simple. They are directly solvable. All you have to know is the basic formulas. Okay, when you know the basic formulas, easily you can solve them, right? Okay, so here is another question, but we are reaching, say, level 3, level 4 questions here on a scale of 5. Okay, let's just say we have level 5 questions. 5 is the toughest level, and this one is at something like 4. Okay, so a man holding a rifle. Okay, a man is holding a rifle. The gun I showed you, a bullet firing scenario. That is what they are speaking about here. Okay, so the mass of the person and rifle together is 100 kg. Okay, the person and rifle, both their weight added becomes what? 100 kg. So they are standing on a smooth surface and fires 10 shots. He is firing what? Not once, not twice, but he is firing 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Horizontally in 5 seconds. Okay, in 5 seconds he is doing this. Okay, each bullet has a mass of 10 gram with a muzzle velocity of 800 meter per second. So the velocity with which the rifleman attains after firing shots will be, okay, what will be his new velocity? That's what they are asking. Okay, so when you see a question like this, first scenario you have to think about is what? So the momentum, okay, before and momentum after, both should be what? Equal. That's the first thing. Okay, so momentum right before first, before firing plus, I'll just take it as P1 and this one as P2. Okay, momentum after firing. When I add both these, the answer should be what? 0. This is the basic scenario, right? So what we are going to do is we are going to divide this into 2 scenarios. Okay, so one is, okay, the formula for momentum is what? mass into velocity. So for before, I will write as B and B. Okay. And for after firing, okay. So here the mass is going to be MA VA. It should be equal to what? It should be equal to 0, right? Okay. So first scenario, before firing, okay, what is the mass of the bullet and how many times does he fire? He's putting up 10 shots and mass of each bullet is what? 10 gram. Okay. So what I'm going to do is 10 gram, right? So gram now you have to convert it into kilogram. Sir, but why should I convert? Because the options are in meter per second. They are in SI unit. Okay. If the option is in SI unit, you have to convert it into SI unit. So, sir, what should I do to convert? Simple. You have to multiply it by 10 power minus 3. 10 into 10 power minus 3 in place of mass. Okay. So what is the velocity they have given? Okay. With a muzzle velocity of 800. So into 800 plus. Okay. Total mass of the person and the rifle together is what? It is 100. Okay. So mass after firing. Okay. He has fired, right? So the person should weigh 100 kg. And what is the velocity? VA equal to 0. So this is how we are going to solve this. Okay. So now what are the terms we have here? We have 800, we have 10 and 10 power minus 3. So 10 into 10 power minus 3 becomes what? 10 into 10 power minus 3 becomes 10 power minus 2 into 800. See 10 power minus 2 and these two zeros, they will cancel each other, right? So if they cancel each other, then we'll just have 8 only. Okay. So VA, okay, is equal to minus 8 divided by 100. Okay. So just one small thing. Yeah, not small thing. We have to just divide this. So minus 8, if you divide it, okay, by 100, what is the answer you get here? 0.08 meter per second. That's it. So every one of you please check whether you get this answer. Okay. So C is correct. Who says it? Shiva Ranjini says she is correct. Okay. So everyone, have you understood this question first? Everyone got C. Yeah. Should I repeat it again? Sir, if it will be better if you repeat it again, then I will surely repeat it again. Okay. So everyone gets the answer C. Yeah. So minus. That's a good thing. Okay. So see here the problem is, okay, the answer with the minus sign is not there in the option. Okay, the answer with the minus sign. For example, we have got 0.08 meter per second. Okay, but is minus sign in it? No. Actually, see, look at D. It is just minus 0.8 meter per second, not 0.08 meter per second. Okay. Or we should have made some mistakes here, but I don't think there is any mistake here. We have done it right only. Yes. So we have done it right only. Okay. So there is no problem. The minus sign, if it is not in the option, then you don't need to worry about it. The right answer, but there is no minus sign, you don't need to worry about it. So why? Because the minus sign just represents the direction. Okay. And not every time they will give the minus sign in the option. Okay. When it comes to entrance examination, most of the times the negative sign, it will be ignored, okay, in the option. If it is ignored in the option, if it is not in the option, you can ignore. Okay. But if there was an option, like if C had minus 0.08 meter per second, then what should you choose? Definitely the minus one. Okay, the one with the minus only. If it is given, choose it. If it is not given, you don't need to choose it. Okay. So yes, okay, sir, understood. And who says that? Saigita says okay, she understood. Fine. Super. Now we'll move on to another very important topic, but another interesting one. Okay. And it is friction and types of friction. Okay. So first thing, your first rule actually, you have to understand something about friction is when you're giving a force and trying to move an object. Okay, here is a mass M and I'm trying to move it. So for that, I'm applying a force F. Okay, the friction will always act in the direction opposite to it. The friction will always act in the direction opposite to the force which you apply. Okay, so what friction does? It always opposes the motion. Okay, what friction does? It always opposes the motion. So that's the first thing we have to understand here. Okay, so next, the static friction. Okay, so there are two types of friction here. One is static, the other is kinetic. So what is static? Let's just say here there is a mass M, okay, and I am trying to move it. I am applying some force on it, but actually it is not moving. It is not what? It is not moving, okay, but still I'm applying a force here, okay. So in this scenario, the friction that exists here, that is what we call it as static friction. Okay, sir, what is the static friction? I want to understand this very simply, sir. Then I will tell you an example, a scenario. Okay, let's just say we are trying to move an object. In order to move that object from this place to another or just move it, we have to apply a minimum force. Okay, see, if I want to move this pen now, I have to apply a minimum force. That minimum force only will move this. If I don't, apply the minimum force, I'm just blowing some air. Okay. Will this force be enough to move this pen? No. But did a force act on this pen? Yes. The only problem is the force was very less. The force couldn't move the pen. Okay. That is the same scenario here. The force that I'm applying, it is not enough to move the object. So in order to move a particular object, you have to apply a minimum force. Okay. So that minimum force or minimum friction, okay, or the maximum friction, that is what we call it as static friction. So static friction is a force which opposes the initiation of motion. What does it do? It opposes the initiation of motion. Due to this friction only, when you push an object, it is not moving immediately. There is some opposition. So you have to give a force which is greater than the static friction. If you apply a force which is greater than the static friction, then it will move. Okay, then it will move. So the magnitude of static frictional force, okay, the value will be what? Static friction Fs will be equal to mu s into n. Sir, what is n and what is mu s? I don't know what these two terms are. This is the first time I'm hearing about them. Then I will make life easier for you. You know Newton's third law, right? Every action has an equal and opposite reaction. So by that law, any mass, its weight will act downwards due to gravity. Okay, due to gravity, whatever the mass, okay, it always gets attracted what? Downwards, right? So if there is a downward force, then according to Newton's third law, there should be an equal and opposite force, that is upward, right? So that force, that is what we call it as normal n. Okay, so this normal n, it is equal and opposite to what? Mg. Okay, mg is downward. So equal and opposite is what? Normal. So normal is equal to what? Mg. Okay, normal will always be equal to mg. That's why in place of normal n, we are substituting mg here. Okay, so now you know what is normal. Okay, sir, what is mu s then? Well, mu s is coefficient of static friction. Okay, sir, what does this value represent, sir? It represents the surface. It is the value of the surface. Okay, see, a surface, depending upon the nature of it, can have different types of frictional values. For example, if we are trying to move this mass on a very rough surface which has lots and lots of stones, okay, it has pebbles, stones like that and all, then it will be very hard to move it. Say if the whole the surface is very plain, shiny, and it is fully like wet with oil, okay, if it is fully covered in oil, the whole surface, then it will be very easy to move this mass. So the surface, it has some particular property. That property will increase or decrease the friction. So that measurement only we call it as mu s. So you can even note it down. If you don't know, you can note it down. Mu s is coefficient of static friction. They might ask it as a theory question also. So it is good that you actually note it down. Okay. And what is N? N is the normal force exerted by the surface on the body. It is a normal force. Okay. We call it as a normal force exerted on the body, right? So everyone has understood what is static friction. If you have understood what is static friction, Abdina, you can put some emojis. That's right. Okay. So there are lots of emojis. Fine. Super. Actually, you could just come up with the thumbs up button, or there are different emojis. I want to know what are the emojis there are. So there is heart, there is thumbs up, there is a laughter thing. Okay. So we have very handful of emojis only. So there is some shock and okay, I get it. Fine. So let's come up with different emojis then, right? The same one gets boring, and you like if I take the class the same way for the whole 2 hours, you will get bored no matter how good I teach. Okay. Likewise, if you stay the same, okay, you're just listening, putting your headphones and listening, you're sitting on a chair and listening, you're doing nothing, I will also get bored. I want you to be interactive. I know the interaction is very limited here. Okay. It's not like you're in a classroom and you could ask whatever. I know the scenarios, but still we can find a way to be more interactive, right? So we'll continue that. Now we will go to kinetic friction. Other type of friction we are going to see here is kinetic friction. So if the external force acting on an object is greater than the maximum static friction. Last time we saw about static friction, right? So if the external force we are applying is greater than the static friction, then what will happen? The object will start to move. Okay, what happens? The object starts to move. Okay, so while it is moving, it is having some friction, no, in motion. That friction is what we call it as kinetic friction. So when an object slides, the surface exerts a frictional force called kinetic friction. When an object slides, okay, it is moving, the surface exerts a frictional force. That is what we call it as kinetic friction. And look at the formula for kinetic friction. Again, what is it? Instead of mu s, okay, s represented static. Here we have put on mu k. K represents kinetic. And again, here is n only. And for n, we are going to regularly substitute mg just like last time. So the formula actually hasn't changed anything, right? Again, if you see here, Abdina, mu k, it is a coefficient of kinetic friction. And what is n? N is normal force exerted by the surface of the body, right? So kinetic friction and static friction, technically, problem wise, okay, as concepts, they are different. One is in static rest, the other is in motion. But problem wise, they are the same thing. They're same formula. In a question, you will have what? You will have the value for coefficient of friction, and the other value will be normal. And if you multiply both these values, you will get the answer. It is very, very, very simple. Okay. So I think it is very simple, and I think you have understood it, right? So again, it's time to show whether you understood it or not, right? And I also check whether you have put up some doubts. These are all from... Okay, pa. I don't think there has been any doubt in physics for some time. Right. So yeah, the emojis are here. Okay, fine. So now we will continue. Okay, like we are going in for some black territory. Okay, the background is going to be black for some time. Okay, so now we are going to see about laws of friction and the angle of friction. Okay, so how do you find the angle of a friction? I will just explain it to you. For that, I'm going to take a very, very rough surface. Okay, what is it? A rough surface. Okay, so in this rough surface, I'm going to place a mass, okay, a box, a mass, whatever it is, okay. And what I'm going to do is I'm going to try and pull it with a force. Okay, so here is a guy, okay, this guy is pulling it with a force. Okay, but what do we know already about a mass? If there is a mass now, acceleration due to gravity or the weight of the object will always be what? Downwards towards the earth. If you release an object, it always drops towards F, right? So its weight should be downward. Then what did I say? If the weight is downward due to Newton's third law, that normal will be upward. So here also in this diagram, I have put in the weight mg downward and normal n upward. Okay. Also remember one more thing. I said that the direction in which you are applying the force, okay, which is this direction, right? I'm applying force in this direction. So friction should be opposite to it. Friction should be opposite this direction. So what I have done is, see, friction, okay. Just a minute. I'll just change the color. Since it is blue, it is not like we can't see it here. Here is a friction. Okay, sir, you put an FL, sir. You said there are two types of friction. One is static, the other is kinetic. You did not say what is FL. I can see that F is friction. What is L? Here L is limiting. Sir, what is limiting, sir? It is another name for static. Both static and limiting friction are same. You don't need to confuse with them. Okay, so it is another name for static friction. That's it. It's very simple. Okay, so you are applying a force and the frictional force is opposite to it. Okay, sir, I know what is weight. It is downward. Normal is upward. Okay, I am applying a force and in opposite direction there is friction acting. I can understand all this, sir. Fine, sir. Super. What is this one, sir? There is some angle theta and another line going in some particular direction. So what is this? Well, it is a resultant. Okay, so that is what I'm going to explain to you here also. Okay, when two forces, okay, listen to me very carefully. When two forces are acting perpendicular to each other, then there will be a resultant between them. So what are the forces? One is normal, the other is limiting or static friction, FL. They are like this. They are perpendicular to each other. Okay, so the normal is acting upward, then this frictional force is perpendicular to it. So what happens is, okay, there is a resultant force between them, and this resultant force is what we call it as FR, resultant. So we are putting R there. Okay, so the angle between normal and resultant, okay, this angle, that is what we are taking here as theta. Okay, the angle between the normal and the resultant force, it is what we are going to take it as theta. This theta only we call it as angle of friction. So in a question, if they ask you to find the angle of friction, they are asking you to find the angle between the normal and the resultant force. Okay, this is what we have to remember. So now what I did is I just took all these things, these boxes, these scenarios, the man pulling it all, and I'm just going to represent it like a diagram from the book. Okay, so here see, look at here. There is a mass M. Its weight is downward. Normal is upward. I am applying a force F, and in opposite direction friction is acting. So what happens? The normal and frictional force, they are perpendicular to each other. So there is a resultant between them. Okay, there is a resultant between them. So here what I'm going to do is I'm going to use the formula tan theta. Okay, what I'm going to use? I'm going to use tan theta. You can blindly, okay, again, I will mention it very, very clearly. You can blindly follow one thing. If they ask you to find the resultant, then the angle will be tan theta only. Okay, definitely the angle will be in all resultant problems. The angle will be what? Tan theta only. I will explain how. Okay, see here, N is acting upward. Okay, and then FR, resultant, is acting in this direction. Now what I'm going to say something new to you is the frictional force FL. Okay, I'm going to put it like this, FL. You see, in the smaller diagram I have put up. Okay, I want you to look at two things. One is magnitude. Okay, one is what? Magnitude. So here the magnitude of N, okay, is just N. And what direction is it? It is in upward. In this larger diagram, look at the direction of N. It is also upward. Fine. Look at the direction of, say, resultant force FR. Okay, resultant force FR is at a direction at an angle theta. In this diagram also, it is at an angle theta. Okay, fine. Now come to frictional force. See, frictional force in this diagram, for me, it is towards left. Okay. Since you are watching the video, I think it will be mirrored for you. For me, the place where I am standing, it is towards my left. Okay. So in this diagram also, it is towards left. So technically, both the magnitude and direction, they are same in both the diagrams. In diagram 1 and the smaller diagram 2. In both these diagrams, the magnitude as well as direction, they both are same. Okay. And what I can see here is FL, it is in opposite direction, and normal is in adjacent direction. So opposite divided by adjacent gives what? Tan theta. So tan theta is equal to FL, limiting friction, divided by normal L. And limiting or static frictions formula is what? Mu into N. Sir, mu S or mu K, we have to put no. Mu S represents static, mu K na it is kinetic, but you have just put mu there. I already said to you, it doesn't matter when it comes to solving a problem. Okay. Either it is static or kinetic. You can just substitute here it as mu. If they give us kinetic friction, substitute it in the place of mu. If they give it as static friction, substitute it in the place of mu. That's all. So it is not compulsory that you have to write it as mu S or mu K. Why? Because it is not like your school exams. No one is going to come and ask you. They're not going to come and ask you a rough sheet like, hey, come on here, how did you solve this? Show your rough sheet. Are they going to ask those things? No. So you can save time. You can be very sharper here. Shariya. So here n gets cancelled. So then what we will get? Tan theta is equal to mu. Okay, tan theta is equal to mu. So from this, you can say that the angle theta or angle of friction is tan inverse of mu. Okay, angle theta is equal to what? Tan inverse of mu. So this formula is a formula for angle of friction. Okay, it is a formula for what? Angle of friction. So everyone has understood this formula. Everyone, if you have understood this formula, Abdina, then it's time to show. And if you have not understood Abdina, please put it in the comments. I'm waiting for your comments. Okay. So yes, I can see those things. Are there any doubts now? No doubts. One doubt is there regarding physics. And it is Nath video upload pannunga sir. We have already did it, I think so, right? Please check our app. We have actually uploaded it. Okay, va. So, yaar Nath class varla. Okay, Sai Subramani, HS Sai Subramani. Yes, it will be uploaded in the app. I think, please check it out. I think it is already uploaded in the app. I remember seeing it in the morning. Okay, just a second. I will also get some water. You also, if you want to have some water now, you can have it now, right? Nanda wireless. Yes. And Sai Subramani says no. Okay, Sai Subramani, I will check it for you. Okay, definitely I will check it for you and I will update you. Okay. Okay, fine. Now we will continue, right? So angle of friction, everyone has learned, right? Now we will learn about angle of repose. Sir, what is angle of repose? It is again the same scenario, okay? But this time the ground is going to be inclined. See, last time the surface was flat. This time, how was it? It is inclined, okay? So what we are going to do here is we are going to place a mass M on an inclined surface, right? If you place it now, what will happen? It will slide down. But in order for it to slide down, okay? Say, I will put up an example for you like this, okay? So see, here is a remote, okay? And I'm going to place it on this notebook. It is better, okay? So I'm going to place it like this, okay? Here, if I increase the inclination, what happens? It starts to slide down, but it starts to slide down only at a particular angle. Only if I place, if I increase it to a particular angle only, it will start to slide down. So at what angle this happens, that is what we call it as angle of repose. Okay, so here is a mass m, and what happens, every mass, its weight always should be what, downward. So its weight mg is downward. Okay, but in an inclined surface there is one problem. What is it, sir? It's very simple. This inclined surface is there? No. This is what we take it as x-axis. And the normal, no, this line is what we take it as y-axis. So is mg along x-axis or y-axis? Well, it is not in both. It is in between them somewhere. So what I'm going to do is, along x-axis and y-axis, I'm going to separate it into two different components. So one is, okay, mg sine theta. Okay, mg sine theta, this is along x-axis. mg sine theta is along x-axis. The other is mg cos theta. Okay, mg cos theta, it is along y-axis. And you can see here that the mg cos theta is equal and opposite to normal. Last time, okay, last time what we did is, we wrote it like this: n is equal to mg. If in a question they mention the word inclined, if we see a word called inclined surface, okay, then what I want you to do is, you have to write normal as mg cos theta. Remember this very, very, very well. Okay, in a normal surface, in a flat surface, okay, normal will be equal to mg, just like last time I taught you. Okay, but if it is an inclined surface, then normal will be equal to what? Mg cos theta. You can look at the diagram also here. Normal is upward, abdina. It is equal and opposite to what? Mg cos theta. Okay, so it is equal and opposite to mg cos theta. Remember this. Okay, and furthermore, you can also see the friction will always be opposite to direction of motion. And what force causes the motion? Mg sin theta. So you can say that mg sin theta is equal to frictional force Fl. Okay, so mg sin theta will be equal to what? Frictional force Fl. What we can do is, this is 1 and this is 2. We'll take and write both these formulas in a separate page. Okay, we'll take and write both these formula in a separate page. And the angle of inclination here, I'm going to take it as theta. The angle in which the surface is inclined, I'm going to what? Take it as theta. Okay, so what we know now, 1, n is equal to mg cos theta, right? So in this formula, the first condition, what I'm going to do is, I'm going to substitute limiting friction Fl is equal to mu into n, which I taught you earlier in today's class itself. I said to you, friction, the formula for friction is mu into n, coefficient of friction into normal n, right? So we are going to substitute this. Okay, so look what happens here. Okay, I'm going to bring the value of n and I'm going to substitute here. In the place of n, mg cos theta. So limiting friction or static friction is equal to mu into mg cos theta. That's a formula that we will get here, right? Once we got this formula, then we are going to take and write the second one also. Force F is equal to mg sin theta. Sir, what is force? Okay, you said that Fl only will be equal to mg sin theta, you said. But here it is putting, they have written it as pulling force. Yes, the pulling force is the force that is pulling the mass downwards. Okay, since it is coming downwards, mg sin theta is a force, right? Okay, the mg sin theta is a force and it is the one that is pulling it down. That's why we call it as another name. We call it in another name as pulling force, and the pulling force F is equal to mg sin theta, right? So what now we are going to do is, we are going to equate these equations. Okay, we are going to compare these equations and we are going to equate them. You just remember it. Okay, I will tell you when I am comparing them. Okay, so from this formula, what am I going to do? Okay, there is a critical angle called angle of repose alpha. Okay, there is an angle called angle of repose, which is denoted by alpha. Okay, at which the two forces, one is FL, the other force F, they are equal. The frictional force and pulling force, okay, the net force downward, the net force due to friction upward, they both are what? They are saying that it is equal, they will be equal. And if they are equal, abdina, what happens? Now, if theta is further increased, okay, like this notebook, okay, it is initially at this angle. I'm going to increase it even more. I'm increasing theta even more. So when I'm increasing like that, what will happen? The driving force F becomes more than the limiting friction FL. The force downward will be more than the friction that is upward. Okay, so when the downward force increases more than the upward force, the block starts sliding. Okay, the block, what will happen? It will start to slide. Okay, so FL and F, okay, force due to friction and pulling force, when they are equal, theta's value will be equal to what? Alpha. Theta and alpha will be equal. Okay, so for FL, mu mg cos alpha, and for capital letter F, that is a pulling force, mg sin theta. And both the sides we are going to cancel mg, mg. The terms mg, mg will get cancelled. Okay, and here there is cos theta, sin theta. So sin alpha divided by cos alpha will be what? It will be tan, right? So that's why we have written it as tan alpha is equal to mu. So you can see that alpha is equal to tan inverse of mu. Now, I want you to look at something. Tan inverse of mu. What is tan inverse of mu? Just before I also thought another formula that also said tan inverse of mu. What was it? Can anyone put it up in the comment? Ashiv, yes, I did see that. The notes part, I have updated it now. It will be updated now. Okay. I studied this topic before 20 months. Nice topic, sir. Yeah, it's a very interesting and nice topic, actually. I kind of like it very much. Angle of friction. Yes. Okay. Harshiv, you're right. Angle of friction. So, see, when you look at it like a concept, it is different. Okay. But both angle of friction and angle of repose, they both are what? Tan inverse of mu only. Okay, we either put it as theta or alpha. Okay, but both angle of friction and both angle of repose, both of them, they are equal to what? Tan inverse of mu only. So when you're solving a problem, you don't need to worry whether they are asking angle of repose or angle of friction. For both, it is the same formula. So it will be very easy to solve, okay, as a mathematical problem, right? So now I will tell you some important conditions, and I want you to note down these conditions. And what are the conditions? If the value of theta is less than alpha, okay, the angle in which it is inclined, theta, if it is less than alpha, then the block will be stationary. It will not slide down, okay, it will not move down, it will stay there. Okay, so here the pulling force will be less than the frictional force. Capital letter F here is what? It is the pulling force, and FL is what? It is frictional force. Okay, so the frictional force is more, whereas the pulling force is less when theta is less than alpha. This is the first scenario. Okay, so I want you to write it down. That is very important. Okay, so the next scenario is theta is equal to alpha. Okay, the angle of inclination and angle of repose, they both are what? They are equal. Theta is equal to alpha. In this scenario, both pulling force and frictional force, they will also be equal, and the block is on the verge of sliding. What does it mean? What does it mean that it is on the verge of sliding? Abdina, it has not started to slide down, but it will start at any moment. At any given moment, it will start to slide. Okay, but not yet, not just yet. Okay, and the third scenario, so when will it start to slide? Now it is on the verge of sliding. Okay, when will it start to slide? For that, the value of theta should be greater than alpha. when the value of theta is greater than alpha, then the pulling force, what will happen? It will increase. It will increase more than the frictional force. And the block, what will happen? It will start to slide down. Okay, it will start to slide down with some acceleration. Okay, so everyone, you all got all these three scenarios. Okay, so I'll just move to the reaction time. Everyone has understood this. Everyone has got it, right? Okay, very good. Also, of course, you're all putting up emojis, which I asked you to. Okay, but it will be fine if some of you did some interaction with me also. Like there is the same set of students, 4 5 students that are interacting, whereas the others, you're not asking any doubts. You're staying very, very silent, and there is not much interaction between you and me. Okay, I want that to change. Okay, I want more interaction to happen so that I can be clear that you have understood and that you don't have actually any doubts. Because no matter how good someone teaches, at some part of the class, no matter how good a student listens, they will have some trouble there. They will have some understanding issues. Okay. And sometimes in normal classes, what we do, we'll hesitate to ask that out. Okay. When we are with 50 students in a classroom, sometimes we might hesitate. Okay, what might they think about us? What might they think about me if I ask such a silly doubt? What if the teacher said that it is very silly? For these reasons, you would have not asked any doubts. You have completed your school, right? Now you're grown up. You can ask whatever the doubt you have. There is nothing to be worried about. So always please ask the doubts, right? So I hope you do ask your doubts. Okay, fine. Now we will come to the problems which are based on friction. Okay. So question number 5. Okay. Here a block, sorry, just a 30 kg block rests on a rough horizontal surface and a force of 200 Newton is applied on the body. The block acquires a speed of 4 meter per second starting from rest in 2 seconds. What is the value of coefficient of friction? Okay. So first, what they are asking us to find the coefficient of friction, which is mu. Okay. They are asking us to find the value of mu. And what are the values they have given us? Let's see the values they have given us. First, they have given the mass. Mass is 30 kg. Okay. And they have given the force. The value of force is 200 Newton. The block acquires a speed of. So they given the velocity, which is 4 meter per second. And it is starting from rest, which means the value of u will be equal to 0 and time period is 2 seconds. So what is the value of coefficient of friction they are asking? Okay, so it looks like a very, very tough question, okay, because the question is somewhat big and the values they have given here are somewhat convoluted. Like if you want to find the coefficient of friction, abdina, what formula you can use? Friction is equal to mu into n or mu into mg. This is a formula you know, right? But for that, you need mass and acceleration due to gravity and the value of friction. But is the value of friction given in the question? No, they haven't given it in the question. But other than that, they are given some other values which have the velocity and other things. Okay. So first, what we have to do is we have to use the equations of motion that we learned yesterday. Okay. What I'm going to do here is I'm going to look at the values. There is u equal to 0. The final velocity v, 4 meter per second, and there is t. So I'm going to use a formula. V is equal to u plus at. Okay. And by using this formula, I'm going to find the value for a, because the acceleration is not given in the question. So I'm going to find the what? Acceleration. So first 4. Okay, v uடைய value, what is it? It is 4. And what is the value of u? It is 0. And what is the value of a? That is what we are going to find out. And what is the value of t? It is 2. So 2 and 4 cancels and a will be equal to what? 2 meter per second square. The value of acceleration a will be what? It will be equal to 2 meter per second square. And from this, what I'm going to do is I'm going to find the value of, okay, mass. Okay, I'm going to find the value of what? Sorry, we can find the value of friction, because in the question, what I said earlier, there is no value of friction. Okay, they've given the mass. Okay, but there is no friction. So how to find the friction? That is the next question, right? If there is a block M, okay, and there is 200 Newton force acting on it in one direction, we know that the friction will be acting in the opposite direction. So the total force acting on the object is what? F is equal to 200 minus frictional force FL. Okay. See, a block, a mass, a 30 kg block, they are saying no. On it, there is 200 Newton force acting in one direction. So what I said earlier, if there is a force acting in one direction, then the frictional force should be opposite in the acting in the opposite direction. So the total force on the object should be what? It should be 200 minus FL, right? So we have written the force like this. Okay. Now what I'm going to do is, okay, I'm going to write the formula like this. Force is equal to mass into acceleration equal to 200 minus FL. Okay, 200 minus FL. And now, okay, acceleration. We know the values for both mass and acceleration. What is mass that is given in the question? Mass, they have given it as 30. Okay, they've given the value as what? As 30. Into what is the acceleration? We have found it as 2, equal to 200 minus FL. So 30 into 2 is what? 60, right? So 60, we have to subtract it from 200, and we subtract it now, we'll get the answer easily, which I will do it in the new page. Here, see, 30 into 2, I'm going to write it as 60 equal to 200 minus frictional force FL, right? Now, okay, 200 minus 60 will be equal to the frictional force FL. So the frictional force FL will be equal to 140. It will be equal to what? It will be equal to 140. That's it, right? Now, okay, we have found the frictional force. What did they ask actually? The value of coefficient of friction. That's what they asked, right? So we will write the formula. FL is equal to mu N or mu mg. Okay, and here we need to find the value of mu. So what is the value of frictional force? 140 equal to mu into what is the mass? Mass is 30. Okay, and the value of g is what? The value of g is 10. Acceleration due to gravity, g equal to 10 meter per second square. So 140, okay, divided by 300. So it is 14 divided by 30. So 14, if you divide by 30, abdina, you will get 0.467. So one thing I want you to do now is you also solve it and check it. 140, sorry, 140 divided by 300. Okay, so when you solve it, you get 0.467, the value of mu. Okay, so now what I will do is I will see which option matches. Okay, so what are the options here, Abdina? There is 0.47 and 0.185. Definitely it is not 0.185, but it can be 0.47. Why? Because here what the answer I got is 0.467. Since it is 7, I can add 1 here, so it can be rounded off to 0.47. So here the right option is what? Option C. Okay, so now everyone has understood this problem, and any one of you are having any doubt in this one? Okay, if you are having doubt, Abdina, please always put it in the doubt section. If you have understood now, you can go with the emojis. So there is one emoji. So that means only one has understood. So there is 2 and 3 and 4 and 5 and 6, 7, 8, 9, 10. It is getting out of hand. More emojis than more students. Just put up the emoji once so that I will take it like attendance. How many of you? Or raise hands so that I can see that how many of you have understood this. So that is 1 and 2. What about, yes. What about Ashwin Kumar? Have you understood? Atmiya, DN. Pranav, Kamalika, Mitra, have you all understood? You're not putting up your hands. Have you all understood or what? Okay. So you haven't put up anything. So are you even listening? Yes, understood. Okay, fine. If you have any doubts, kids, please do put it up and please be interactive so that we can learn a lot. Okay, if you're not interactive now, you're not going to learn anything. So yeah, Mitra has put up a hand. Very good. Now we'll move on to another question, the problem 6. A block of mass 2 kg is resting on a rough inclined plane of inclination 30 degree. So the coefficient of friction is 0.8. The contact force between the incline and the block is. They are asking us to find the contact force between the incline and the block. Okay. So what are the things they have given? Again, they have given the mass, which is 2 kg. Okay. And here they given the value of theta, which is 30 degree, and coefficient of friction mu's value they have given it as 0.8. Okay. And what are they asking? They are asking us to find the contact force. Now, what is contact force, sir? This thing I want to clarify it for you. Okay. We know that there are two forces acting when there is a mass. Okay. The two on an inclined plane, if there is a mass அப்படின்னா, there are two forces acting on it. One is downward, the other is upward, right? So here there should be a resultant force. Remember me saying that there will be normal force N and there will be frictional force FL. So due to this, what I said is there will be a resultant between them, FR. Okay, this resultant is what they are asking us to find. They are asking us to find the what? The resultant. So if you need to find resultant FR abdina, then what is the formula for it? Well, resultant, they say resultant nale, it is very simple. What are the other two values? One is FL, another N, right? So both these values, FL square plus N square. You have to follow parallelogram law or triangle law, and for to calculate resultant, you have to take root of FL square plus N square. The resultant means this is the formula. This is the way you calculate it, right? So you have done, you have written the formula, but the problem here is no, you don't know what is the value of FL. You don't know what is the value of N. When you actually don't know the value, how can you solve it? Then we have to find the values. So let's just solve FL. So what is the formula for FL? It is mu mg, right? And what is the value of mu? 0.8 into what is the value of m? Well, the value sorry, and the value of m is here 2 kg into g's value is 10. And one more thing we should not forget here. Sir, what should we not forget here? This is inclined plane. I already said to you what to do if in the question they give it as inclined plane. Then in place of normal, you have to substitute cos theta, mg cos theta. So never forget that. Always double check the question. If they given inclined, the word inclined, okay, mu n, you substitute no. So in the place of n, you have to substitute mg cos theta. Okay. So 10 into cos 30 degree. Okay, we have to substitute like this, cos 30 degree. So what is the value for cos 30 degree? It is root 3 by 2, right? So 0.8 into 2 into 10 into root 3 divided by 2. So what happens? 2 get cancelled. Okay, there is 0.8, there is 10. So if you multiply now, it becomes 8. So it is 8 root 3. The value of frictional force FL. Okay, the value of frictional force FL is what? 8 root 3. So everyone got this part right? FL, how we derived, everyone is clear? Please put up your emojis, or if you have doubts, Abdina, you just look at the comments also. So there is literally 3 emojis and others. There is more. Okay, fine. See, I know that the sums are very much different to the sums that you practiced yesterday. Okay. with each and every class, we'll start to practice more bigger, more tougher problems every now and then. Not all the problems you are going to solve are going to be very tough, not very big, but there will be some big problems because we have to solve them also, right? We have to get the marks, we have to get the seat that we desire, we have to go to the career of our dreams, right? So for that, we have to solve these tough sums, somewhat big sums also, but I will make it very, very easier for you. Okay. Any doubt, you can always ask me. I will make it very, very easier for you. You just make sure you ask the questions. Okay. So now see, we have calculated the formula for friction. The another one is normal. Okay. We have to find the value for what? Normal. So the value of normal, I will find it in a new page, right? So if we want to find the value of normal, okay, then it will be equal to what? It will be equal to mg, sorry, not it will be equal to mg sine theta, right? It will be equal to mg sine theta. One is cos component, the other is sine component. So here what I'm going to do is, again, mass is 2 into gravity is 10 into sine 30 degree. We have to put sine 30 degree here. So 2 into 10 into sine 30 is 1 by 2. So 2 gets cancelled. Then here the value will be what? F. Okay. So the force here is, it is 10. Okay. So now what we have to do is we have to calculate the resultant, right? So see how I calculate the resultant here. Okay. The contact force, resultant force will be equal to, one of the value is 8 root 3 whole square, which we found it here. Okay. The other value we have found here is 10 square. Okay. So we just have to calculate this. So when you square 8, 8 8s are 64. And root 3, when you square 9, it becomes 3. So 64 into 3 is 192. Okay. So 192 plus 100. So FR, the value of FR will be root of 292. Okay. The value will be what? Root of 292. But the problem here is, okay, is the value root of 292 will be equal to any of the options given here. Can it be A, can it be B, or can it be C? Is there any chance for it to happen? Root of 292. Does it match with any of the option here? You can put it in the comments. If you think it matches now, you can put it. If it doesn't match now, you can say no, sir. Yes, none of these. Okay. Many times, when there is an option called none of these, we might think, no, it is there to confuse us. But sometimes, in order to confuse us itself, they will give a question for which none of the answers actually come. So here, okay, we have found the correct answer, but it is not in the option. So we have to choose none of these, right? So what is the answer we have got? Root of 292. Okay. So everyone has understood this summa. Okay. Whenever they are asking the contact force between inclined and the block. Okay. First, mu mg cos theta is one term. The other is mg sin theta. For both these values, you have to find the answers and then substitute it in the resultant formula. Root of FL square plus n square. In this, you have to substitute. Okay. So everyone has understood. I think, I don't know whether you have put up some emojis. And Ashiv is raising his hand. Maybe he has put up a doubt or something. No. So he has put his hands down. Okay, fine.